You're welcome to Excellent Simplified Tutorials.
So laws of logarithm. So the first one here is addition law. So the addition law, first, if the bases are the same, this is log A, this log x in base A plus log y in base A, right? The bases are the same, is it not? If the bases are the same, what you do is just take just one of the base. Then since this is plus, what you do to the logarithm is you multiply. For example, this is what I mean. If you have log 8 in base 2 plus log 16 in base 2, since the bases are the same, 2, what you do, just take 1, so log 2. And since this is plus, what do you do to the logarithm? You multiply, so we say 8 times 16. For the division, for the subtraction law, if they are separated by negative, what you do is you do what? You divide. So if you have log 8 in base 2 minus log 16 in base 2, they have the same base, base 2, base 2. Take just 1, log 2 now. Then since this is division, you divide. Since this is subtraction, you divide. So 8 over 16. Please don't make the mistake of taking this other one over this one. It's always this one over this one. Good. So the third one now, power law. If you have something like this, log, okay, read this thing for me, let me hear. No, I mean this stuff here, just this stuff. What is this? Log. Good. Log x raised to power n in base A. If you have something like this power, just bring it to the back. Just bring this power here to the back. Just use the power to multiply everything. That was why we brought n here. For example, this is what I mean. If we have something like this, log 2, 3 raised to power 3, or let's say 3 raised to power 4. If you're asked to simplify this, all you need to do, just check anytime you see the power, what do? Bring it to the side, right? So this will be 4 times log 3 in base 2. Do you get? So once you see power, use it to multiply the rest. We'll take exercises on this, but just understand for now. Now, power of the base. Now, if the base is raised to a power, remember the other time here it was actually the number that was raised to a power, right? Now, if the base is raised to a power, what you do is you take the reciprocal and bring it and use it to multiply. That is, now the power here is 2, right? If this power was here, we would have just bring it here, is it not? But now since it's the base that is raised to that power, you take the reciprocal, that is 1 over anything here, you bring it here. That's why we have 1 over 2 here. See what I mean here? If you have something like this, log 2 raised to power 5, log 25 in base 2 raised to power 5. What do? 1 over what? 5 log 25 in base 2, right? So just this power, you bring it here. Is it not? You take the reciprocal and bring it here. What if you have something like this? Log 2 raised to power 5, 25 raised to power 2. What do? 1 over 5 log what? Normally, you know this one on its own will come here, right? So you have 2 times. This one will come here, but you take the reciprocal, right? 1 over 5 log 25 in base 2. Do you get? So anytime the power is on the logarithm, the number, you just bring it like that. But if the power is on the base, you take the reciprocal before you bring it to the back, before you use it to multiply. Logarithm of its own base. Log A in base A is equal to 1. This is the reason. Just like when we started, we said A raised to power what will give me A. This raised to power what will give me A. If you have something like this, for example, log 10 in base 10. What we were saying is 10 raised to power what will give me 10? 1, right? 10 raised to power 1 will give me 10. Is it not? Log 100 in base 100. 100 raised to power what will give me 100? 1, right? So anytime you see the logarithm and the base are the same, just know the answer is 1. Do you get? So if, for example, what you have here, logarithm of gift in base gift, the answer is what? It's not gift. The answer is 1. I don't know if you get. Logarithm of peace in base peace, the answer is 1. What will you raise to power peace? Peace raised to power what will give you peace? 1, right? Good. Next one, logarithm of 1. Logarithm of 1 in any base is 0. Remember, here we are saying a raised to power what will give me 1? A raised to power 0 in logarithm, laws of logarithm, we say anything raised to power 0 is what? Is 1, right? Meaning a raised to power 0 will give me 1. If here was 10, 10 raised to power 0, 1. 100 raised to power 0, 1. Is it not? Silver raised to power 0 is what? 1. So logarithm of 1 is always 0. Don't check the base safe, because even if the base is 1 million, 1 million raised to power 0 is still 1. Good. Now the 7th one, reciprocal law. If you have something like this, log b in base a. If you are taking the reciprocal of this whole stuff, what you do is you interchange the number and the base. Like this, I'm taking 1 over. If I'm doing 1 over this, it's not remain the same again. You bring the base here, you bring the number here. For example, if you have something like this, log 8 in base 2, and you are asked to take the reciprocal. You are asked to take the reciprocal. Reciprocal is 1 over, right? To do that, you just say 1 all over log what? Log what? 2 in base what? 8. So anytime you are taking the reciprocal 1 over, you just interchange the base and the number. Do you get that? Good. If you solve this and you solve this, you see that you get the same answer. But we are going to do that. Now, the last one here, change of base. If you want to change the base, maybe you don't like the base, or the base is not working the way you want it to work, you can actually change the base. If you want to change the base, what you do now, in this one, log x in base a, and we want to use the base as n. What you do is just change your base to n. Log n in base x, sorry, log ax in base n, all over that log n, that your new base now, times the original base. This is what I mean. If you have something like this, log 8 in base 2, this is what you want to do, but maybe it's not working. It's giving you issue, and you want to change this from base 2. Maybe you want to change it to base 4. You can just continue to say log 8 in base 4 all over log 4, log what? 2 in base what? In base 4. Anytime you are changing base, feel free, the numerator, just change your base and leave the number like that. Then the denominator, still use your new base and take your old base as the logarithm. For example, again, if you have something like this, log 16 in base 3, and you want to change this base from base 3 to base 5, what do? Log what? Log 16 in base what? 5, all over what? Log 3 base 5. So just your log 5, your log in base 5 is there. Alright, we are going to apply this and we'll see how it works and when to see them in equations. When you see them in equations, they will not tell you use power law, use this law. You'll be the one to know what to do. Can we do that? Let's solve this together. The first one, log 6. Okay, now look at this. Log 16, log 32. Anytime the base is not given, you assume the base is what?
10.
Base 10, right? Yes. That is a natural. That is how it's supposed to be. So anytime you're not giving the base like this, just know it's in base 10. Do you get that? It's in base 10. So in this case here, you're asked to solve. You know, this is the same thing as what? Log 16 is the same thing as what? 16 is 2 raised to power what? Let's bring it to 2 raised to power 2. 16 is 2 raised to power what? 4, right? All over log 32 is what? 2 raised to power 5, right? Good. And remember what we said earlier on. This is power. So what will happen? Take it back, right? The power, what do we do here? We'll take it back. So we are left with 4 log what? 2 all over what? 5 log 2, right? And you agree with me that log 2 can cancel out log 2. We are left with 4 over 5. Alright, let's look at the second one. Log root 7 all over log 7. Now, in this case, who can tell me the first thing to do? Good. So this is the same thing as log 7 raised to power what? Half, right? See, we are still applying indices. It's 7 raised to power half because half is square root. Raised to power half is square root. All over log what? 7 raised to power what? 1, right? 7 raised to power 1 is the same thing as 7 now. Now, what do? We bring the powers to the side, right? So we'll be having half log what? 7 all over what? 1 log 7, just log 7. Is it not? Log 7 can cancel out log 7, right? And we are left with what? The third one now, which I know all of you know the answer already. Log 14 in base 4 minus log 7 in base 4. Yeah. What law are we going to use? The second law, right? Subtraction law. The bases are the same, good and fine. So we'll take just one, right? So what do we do now? 14 divided by 7. Good. So here we are having log 4. 14 divided by 4 is what? 2, right? So how do we solve this? Z? Log 2 base what? From what we have been solving since. How do we resolve this? 4 raised to power what will give you 2? So we will be having, you can equate it the same way we've been doing it, equal to x, right? So 4 raised to power x equal to what? Equal to 2. Is it not? So how do you resolve this now? 2 is the same thing as what? 4 is the same thing as what? 2 raised to power equal to what? Is it not? 2 raised to power 1. So 2 can cancel 2. 2x equal to what? Divide both sides by 2. X equal to what? Alright, so let's look at the first one here. It's called the classwork, and I'm doing the classwork for you. Thanks for those that got it right. Alright, so in this first case here, they are in the same base and this is addition. So what do we do according to the log rule? You multiply, right? So you have log 4, 32 times 2, right? Is it not? So we are having log 32 times 2 is what? 64 in base what? 4, right? And in this case, 4 raised to power what will give us 64? 3, right? So the answer is 3. Is it not? Number 2. Six log 8 in base 4 minus log 32 in base 4, right? In this case, what do we do? You know, this is the same thing as saying log, right? 8 raised to power 6, because if we can bring this 6 back minus log 432. So since they are of the same base now, you can just take 1 log 4 minus, what do we do? 8 raised to power 6 all over what? 32, right? Is it not? If you don't want to stress yourself too much from here, you can just say log 4 brackets is 2 raised to power 3 times 6. Is it not? 8 is the same thing as 2 raised to power 3, right? 2 raised to power 3 will give me 8 times 6 all over 32 is 2 raised to power what? 2 raised to power 5, right? So this is the same thing as saying log 4 brackets 2 raised to power 3 times 6 is what? 18 all over 2 raised to power what? 5, right? From log rule, we know from indices, we know that log 4 brackets, since they have the same base here and division, what do I do? 2 raised to power what? 18 minus what? Minus 5, right? So I'll be having log 2 raised to power what? 2 raised to power what? 13, right? I know this is the same thing as saying 13 log 2 in base 4, right? Is it not? Log 4 in base 2 is what? 2 in base 4 is what? Half. 4 raised to power half will give us 2. Is it not? So everything here is what? Half, right? So 13 times 1 over 2. Is it not? Equal to 13 over 2 is what? Is what? 6 and what? 6 and half. You can use the second method. So let's solve number 3. 2 log 5 plus log 36 minus log 9. So what's the first thing do you think we can do here? We can arrange it, right? What can we do? Okay, let's start the other way we started. You know, this is the same. What's the base here? Base 10, right? I said when a base is not given, just know it's in base 10. I know this is the same thing as saying log 5 raised to power 2, right? Because this power law, we can bring this here. Plus log 36 minus log 9. You can actually solve without bringing it. Now, plus is what? Times, right? So this is like log. Is it not? Division minus is what? Division, right? Is that what you did? If you check this, do you understand what I did here? Plus, meaning just all the bases are the same. Addition, meaning you times it, right? Subtraction, you divide. So in this case here, we have log 5 square is what? 25 times 36 is what? Is what? 900. 900. So 900 all over 9, right? 900 over 9 is what? 100, right? So we have log 100. And you know, remember it's in base 10, right? So 10 raised to power what to give you 100? That's all. There are other methods you can use. Just what we just use here is addition law and subtraction law. Addition law, since it's addition, what you do is you multiply. Subtraction, you divide. That was what we did here.